rate analysis. Okay, we were doing rate analysis. Now, the next problem that we have taken is about plastering. Okay, we are asked to carry out 12 mm thick plastering work in 1:3 mortar. 100 square meter of work is to be done, is to be calculated for 100 square meter, and then the rate, that is per square meter, we have to find out. We have to use sand, that is fine. So first, what we will do, we will calculate the volume of work, 100 square meter with thickness of 12 mm. So 12 mm converted into meter is 0.012 meter. We multiply that with 100 square meter, we get 1.2 cubic meter. This much of plastering work is to be done. Now, in plastering, what we will have to do first, before we go for the 12 mm thick plastering, we shall have to do some kind of making a uniform surface. Okay, there will be joints, there will be non-uniform surface in the brick like this. Okay, so this is the brick wall. These are the mortar joints that one portion is protruding out of the plan of the wall. In some other location, it is inside. So what we have to do, we have to first of all make it as an even surface, and then we have to provide this 12 mm thick plastering, right? So therefore, we will require extra material for this kind of unevenness. So what we are doing, we are increasing the volume by 30% because of this unevenness. If we do that, we are multiplying it by 1.3, that is, we are increasing by 30%. We get the increased volume 1.56 cubic meter. Then again, we also know that we have to increase the dry ingredients, the volume of dry ingredients we have to increase. We have to use the shrinkage factor, because when we shall be mixing the cement, the sand, and the water, it will shrink. And we should consider higher value, this value higher when it is fine sand, and this value can be slightly lower when it is coarser sand. In the previous problem, we used 1.25 or 25%. Here we are using 30%. So this value can be in between 25 to 30%, depending upon the type of material we are using. Okay. So that will be based on our judgment. So we can take 1.25 to 1.30 based on the material. Okay. So here we are considering the maximum limit. So after applying the shrinkage, we get this value. Okay. So first, this value was increased for this unevenness in the joints, and then this volume was increased for the dry ingredients when it will be shrinking, when it will be mixed with water, cement, etc. Then we have the ratio 1:3, and the other things are similar. We require 2 cubic meters of work. Okay, so 1 by 1 plus 3, we get this much cubic meter of cement is required. Now this time, let's do it in a metric ton. Okay, let's do it in tons and kgs. So what we are doing, 0.5 cubic meter multiplied by the density of the cement, we get that this much kgs of cement will be required. Fine. Then similarly, fine aggregate. Okay, easy. Nothing is difficult here. So cement 720 kg. We go to our schedule of rate. We see that this is mentioned there. This is the rate per metric ton. Okay, per 1000 kg. This is the rate. So according to the rate for 720 kg. That's it. Okay. Then for fine sand, this value, and this value. Okay, so this is the rate we are multiplying, and we're getting the value exactly same as we have done in the previous cases. These are now simple. Then how many masons will be required? Okay, when we were studying about work done, we saw that a mason should be able to do 8 square meter of plastering work in a day. Okay, so we require 100 square meter of work. So if I divide 100 square meter by 8, then I get around 12.5. So I am going with 12. You may also go with 13. Okay, so around 12, 13, 14, this type of value of mason we can consider. Fine. So we are taking 12 masons. It can be 13 also. It can be 14 also. It will not be wrong. But if you write 50 masons, then it will be wrong. And we will require one head mason. So we are expecting that one head mason or one expert mason will look after 300 square meters of plastering work. He will oversee the masons which are less skilled in doing the plastering work over 300 square meters. Then we will require mazdurs. We will require Visti. Visti is less because this is a plastering work. This is not a concreting work. Remember, when it is a concreting work, the Visti number will go up. Why? Because we are mixing the material and we are adding water, and there are a lot of water work, higher curing work. Therefore, when RCC and PCC work we are doing, the Visti number will go on increasing. Coolie may be required, but in plastering, those are less, little bit less, but we will require some mazdurs, some laborers to mixing can carry out and bring the items to a place and pumping whatever is required. For those things, we will require few mazdurs. Then scaffolding, sundries and TP, this is a lump sum amount, 1,500, something like that. We have to assume here, and then we get the total labor cost. Then we add, this is exactly similar, total labor cost plus material cost. Then we add 1.5 water charges and 10% contractor's profit, whatever we get, the grand total, we divide it by 100 and we get the rate per square meter. We did our calculation for 100 square meter, and then finally, after dividing by 100, we shall get the rate for 1 square meter. Okay, simple. Next, if I go for neat cement finishing, okay, so this is called khola, when the cement and water is mixed and it is laid over the floor or by the side of the wall. That's for a finishing purpose. Okay, in the floor that we're starting, the thickness of the neat cement layer may be taken as 1.5 meter. So if I do that for 100 square meter, this much volume of work will have to be done. For dry volume of cement, we are increasing it by 25% because here only cement is being mixed. This, and finally, we see that around 6 bags of cement will be required for neat finishing work. Okay, this is for your information. And what is skirting? This is skirting. Okay, this portion is skirting. Earlier, it used to be done with neat cement finishing, but nowadays people do not go for this neat cement finishing. People use tiles most of the time, right? So this portion will be tiled, but earlier this portion used to be given a neat cement finishing. You may see this in old buildings. Okay, going into the next problem. So what do we have to do? We have to carry out rate analysis for 2.5 centimeter thick DPC work. Ratio of concrete is given. 2.5 centimeter or 1 inch is the thickness of the DPC. Ratio of concrete to be mixed is given. 100 square meter of work is to be considered. Rate for analysis is per square meter. We have to use coarse sand and broken stone 12 size, and we have to use Impermo, which are having uh, water resistance effect, okay? Impermeability, which will provide the impermeability, and this has to be used. The rate is also provided. Okay, cost of cement per bag is given to us. So first, Okay, for dry ingredients required. Yeah, I wrote this plastering. This is the wrong part. Okay, this is correct. 100 square meter, and this is the thickness of the DPC. This is the total volume of work, and then the total volume of work is being increased by multiplying with the shrinkage factor for concrete 1.57. Now on that volume we shall calculate what are the cement, sand, and coarse aggregates required. Fine. So we know that already. We can do that. We can find out how many pegs will be required. This point is important here. In Parmo, it will have M. In Parmo or same seal is to be used 1 kg per bag of cement. Okay. So we are using 21 bags of cement. That means we shall have to use Parmo or same seal 21 kgs. That is to be remembered. Then fine aggregate we can find out, and coarse aggregate also we can find out. Then the materials, the same thing. We have the materials. We have found their quantities. We will go to the schedule of rate. This is given to us 450. We multiply, we get the total cost. The other things we shall go to the schedule of rates. So this is broken stone, and there is another one, shingles that are a river sand or river stones. Okay, this one is from the mines that are broken through the plants. Okay, so this rate is slightly higher than the other one. We shall have to go back to our schedule of rate, find out the rate, and just multiply and get the value. This one we shall have to remember that 1 kg is to be used per pig. So we are using 21 kg or 22 kg, something like that, and then we shall get this rate. We shall get the total value. Other things will be similar. We shall go for labor calculations. Okay. Now in DPC, we are taking little more mason because it is a little bit complicated work than normal PCC work. Okay, so we are taking a slightly higher number of masons, and then mazdoors and BSTs low. Not much of mixing to be done. And then finally, we are adding all the cost, adding water charges, adding contractors profit, and finally we're dividing with 100 to get the rate per square meter. Okay, this is fine. So this is